Hello everyone, myself P. Jithendar, Assistant Professor in Electrical and Electronics Engineering, MLR Institute of Technology. So in today's video session, I am going to discuss about the construction and working of single phase transformer. Okay, so here we are going to discuss about the construction and working of single phase transformer. So before that, first, what is the principle of the transformer? So first we need to discuss about what is the principle of the transformer. After that, what is the construction. After that, what is the working. After that, we have to discuss about some types of the transformers. Okay. So here, first we are going to discuss about the principle. So what is the principle of a transformer? So the principle of a transformer is, transformer, it is a static device. The electrical power is transferred from one circuit to another circuit without changing its frequency. That is according to Faraday's law of electromagnetic induction. That means the mutual induction between the two coils. So according to Faraday's law, so the principle is based on the Faraday's law. Faraday's law of electromagnetic induction. That means the mutual induction between the two coils. So according to Faraday's law, the EMF equation E equal to N into d phi divided by dt. Okay, here is the principle of the transformer. So principle of the transformer is, it is a static device. The electrical power is transferred from one circuit to another circuit without changing its frequency. That is according to Faraday's law of electromagnetic induction. That means the mutual induction between the two coils. So according to Faraday's law, the EMF equation is given as E equal to N into d phi divided by dt. So N is number of turns, d phi is the change in flux, dt is change in time. Okay. Now, what is the construction? Construction of a transformer. So here, construction of a transformer which is having the two windings, that is primary winding and secondary winding, right? First of all, we need to draw the core of the transformer. So here is the core of the transformer. This is core. Now for this core, we are having the primary winding and secondary winding. Now we have to give the windings primary and this is secondary windings. Now for this primary winding, we have to give the AC supply. So transformer is a completely AC device, not a DC device. If you are giving the DC supply, the windings may burn. Sometimes the transformer will be lost. So it is completely AC device. Okay. So here is the primary voltage is V1 and secondary side is connected to the load. So load is RL, right? So across the load, we are having the secondary voltage, that is V2 and primary voltage is V1, right? Now if you are giving the supply, what will happen? The electrical current is passes through the primary side. So the primary current is represented as a I1 and the secondary current is represented by I2, right? So here windings are there. So the windings are represented by turns. That is primary number of turns is N1 and N2 secondary number of turns. Similarly, for this primary turns also having the induced EMF is represented by E1, that is primary induced EMF, and this is secondary induced EMF, that is E2. Okay. So here this is the total construction of a transformer. Okay. So V1 primary voltage or supply voltage, V2 secondary voltage or terminal voltage. I1 is primary current, I2 is secondary current. N1 primary number of turns, N2 secondary number of turns. E1 primary induced EMF, E2 secondary induced EMF. Okay. So these are the parameters of the single phase transformer. Right. Now working. What is the working of a transformer? Right. So the working of a transformer is, so we are giving the supply here. When we are giving the AC supply, the electrical current is passes through these windings. Okay. We are giving the AC supply. When we are giving the AC supply, the electrical current is passes through the primary winding. If the current is passes through this primary winding, some amount of flux will be induced. Some amount of flux will be induced. The same flux is links with the secondary coil. The same flux is links with the secondary coil. In secondary side, we'll get the EMF. Okay. So here the flux direction is like this. Here is the flux. Okay. So when we are giving the AC supply, the electrical current is passes through the primary winding. If the current is passes through this primary winding, some amount of flux will be induced. The same flux is links with the secondary coil. The same flux is links with the secondary coil. Then we'll get EMF across the secondary side. That is according to Faraday's law. So according to Faraday's law, the EMF equation is given as E2 equal to number of turns N2 into d phi by dt. So flux is same at primary side and secondary side. Okay. So here the secondary induced EMF E2 is equal to secondary number of turns into d phi by dt. Change in flux, that is d phi. Dt is change in time. Right. So here is the construction and working of a single phase transformer. Okay. So now we are having the different types of the transformer. Okay. So here depends on the windings. So here the first depends on the windings, having the two types of the transformers. So first one is step up transformer and second one is step down transformer. This is depends on the windings. Now depends on the construction. Depends on the construction. We are having the three types of the transformers. So it depends on the construction. Having the three types of the transformer. So in that first one, core type. So core type transformer, and second one shell type transformer, and third one is berry type transformer. These are the three types of the transformers, that is depends on the construction, right? And depends on the phases. So depends on the phases, we are having the two types of the transformers. So in that first one, single phase transformer, and second one is three phase transformer. So these are the different types of the transformers. Okay, so depends on the windings. The transformers are classified into two types. So first one is step up transformer and second one is step down transformer. And depends on the construction, we are having three types of the transformers. So first one is core type transformer, and second one is shell type transformer, and third one is berry type transformer. And depends on the phases, there are two types of the transformers are there. First one is the single phase transformer, and second one is three phase transformer. Okay, so these are the different types of the transformers. Okay, so here, so mainly principle. What is the principle of the transformer here? The principle of the transformer is, it is a static device. The electrical power is transferred from one circuit to another circuit without changing its frequency. That is according to Faraday's law of electromagnetic induction. That is the mutual induction. That is the mutual induction. Mutual induction between the two coils. So here, according to Faraday's law, the EMF equation is given as E equal to N into d phi by dt. And in the construction point of view, so we are having the different parameters are there. For the primary side, we are having the primary voltage or supply voltage, and we are having the primary current, and having the primary induced EMF, and having the primary number of turns. And similarly, for the secondary side, we are having the secondary voltage, that is V2, or terminal voltage V2, and secondary current is I2, and secondary induced EMF is E2, and secondary number of turns is N2. Right? Now here working, so we are already discussed about the working here. So that is according to Faraday's law, we will get the EMF in the secondary side. That is E2 is equal to N2 into d phi divided by dt. Okay, so here we are having the different types. So it depends on the windings. First one is the step up transformer and step down transformer. And in the construction point of view, core type, shell type, and berry type transformers are there. And depends on the phases, we are having the single phase transformer and we are having the three phase transformer. So these all are different types of the transformers. Okay, so thank you, Varanda.